Hello again, everybody, and welcome to another Geo-Institute live stream. It is the third episode in our August series on scour and erosion called Hour of Scour. We tested that out with focus groups around the country, and it was the winning title, and we decided to go with it. Hopefully, you've tuned into our first two episodes. In May, we had Jean-Louis Briot, and over the summer in August, we had Nina Stark. And now we're really excited today to bring you the person who probably is responsible ultimately for the creation of this series. My name is Brad Keeler. I'm the director of the Geo-Institute, and we're really happy to have you with us again as part of our Feast Week. We have new content every single day this week from the Geo-Institute up on the YouTube channel. Yesterday, we had a brand new field trips from GI board member John Foltz. Today, you've got Hour of Scour. Tomorrow, it's Director's Cut and a Geo-Congress sneak preview. Thursday, it's a McAfee live series. And Friday, the latest from the creative brain of Michael Bennett, the Morks Brothers. Little geotechnical comedy for you there to end out the week. If you are here and you don't know anything about the Geo-Institute, after you watch this today, head over to geoinstitute.org, and there you will find out a lot of things about us, including that we are a technical society with about 12,000 members, most of whom are geotechnical engineers and or geologists, and that we are part of the American Society of Civil Engineers. And if you like what you see today, and I feel like our viewers always do, they keep coming back, they should click like, subscribe, and get notifications, and we will let you know every time we post something to the YouTube channel. Again, it is Hour of Scour. If you go back and you watch Director's Cut with our guest today, Rodolfo Sancio, there might be a little bit at the end where we joke about a program called Scour Hour or Hour of Scour, and a couple of years later, here we are, the host of Hour of Scour, and here to tell you, maybe tell you a little bit about Rodolfo and tell you what you're going to see today, the world's best boss. It is Dr. Stacy Kaleza from Texas State University. She's got the giant pencil to prove it. So, Stacy, I guess maybe you're not introducing Rodolfo by the face that you made, but give us some opening comments at least before he does a presentation.
I absolutely will give opening comments. I'm sorry, I have no poker face when I am not prepared for certain things. Thank you for that warm introduction. Yes, I'm Stacy Kaleza. Yes, I am the world's best boss. Most students call me Dr. K. It's backwards, but I decided that this should be my prop for today, and I can point at y'all when I need to get your attention. I am very excited to be here for episode 3. I don't think I am the host. I think I am the co-host because Brad tends to ask just as many questions as I do, and because Brad somehow roped me into this very fun series from which we've gotten very positive feedback overall. Yeah, you know, when this idea for Rodolfo came up, I said, I didn't even know ice scour was a thing. And so then I went and I got to read some papers, and now I'm excited for a more concise version of what I've learned and the opportunity to ask all the questions that I've thought of and all the questions that y'all have thought of. And so our general approach to Hour of Scour is Rodolfo will give us a couple of introductory slides just to get us thinking. I think he has extra supplemental slides if we want to go deeper into topics. So I say we kick it off and learn a little bit just about what ice scour is, and we can then ask our questions. And I will remind y'all again, please use the chat to ask questions. Otherwise, you're only going to hear questions from the thoughts of Brad and myself. The original idea was that Brad brought Stacy so that Stacy could ask technical questions, because I do a lot of research in scour. I'm the director of a coastal infrastructure-focused University Transportation Center, and a lot of our research focuses on scour. And yet, for the past 2 episodes, I've mainly asked ridiculous questions, and Brad has asked very technical ones. Will we change that today? Unlikely. We'll find out. So
stay tuned and find out.
Stay tuned to find out more.
It's called a tease.
Can Stacy ask a technical question? Debatable. So with that, Rodolfo, if you want to, I guess, just tell us what ice scour is. If you want to show your slides, however you want to hop in, let's hop in. Let's get dirty.
So ice scour is a little bit different than the scour that people are used to, in which the shear stress caused by the water takes the particles away. Here you have a moving element, which is the ice, which is running aground on the seafloor. And once it runs aground, the wind keeps on, the currents keep on pushing it, and it creates a gouge and scours the seafloor, right? And so that's essentially ice scour, in a nutshell. But ice is quite complicated when you start looking into it, and why you start looking into it. And so perhaps I'll share my window, right? Do this right. What? There. Okay, sorry for that. So this is the Kashagan field, and it's in the northern part of the Caspian Sea, right off Kazakhstan. So very far from home. But what you see there in the summer months is a drill island, drill center, and it's an oil field. Kashagan is an oil field. And you see some protection barriers, right? Look like breakwaters, but they're really not meant for waves. They're meant to break the power of ice, as you can see in the upper right. Ice is forming in the colder months, creates sheets of ice that, with wind and currents, move, and you don't want them hitting the infrastructure, and so you protect them. And so that's what you see at the surface, right? But underneath those sheets of ice, which sort of stack against each other and create these ice flows, right? And is what looks like a sail on top and a keel at the bottom. And when those ice flows move, right, they can create these gouges and scour the seafloor. And what you see there in that green image is a photo through the shallow water column, and you see just what we're talking about, these streaks of mobile ice that have come through, right, and now melted, and left these gouges and have extensively scoured the seafloor. So therein comes the word of the term ice scour. And so that the other image or sketch to the right is intended to sort of explain the problem, right? It was a drill center I was showing in the previous slide. The purpose of that is to drill for oil, produce oil, right, and gas, and you have to send it to shore for processing. And the way to do that is through a pipeline. And so you got to lay the pipeline on the seafloor, and you got to bury it, so that, also shown in the sketch, that little pipeline that's below the keel of the ice isn't directly damaged, right? And then to show that, you can show something that looks like this. It's a piece of ice that is moving along the seafloor. Sorry, along the sea, and it's run into the seabed. And you have a buried pipeline, and it's approaching the pipeline. And so I'm showing those sub-gouge displacements along the gouge seafloor. And, there's a zone red there that you don't want to put a pipeline. You can't just lay the pipeline on the seafloor because the ice is going to hit it. There's a displacement field. And so if you put the pipeline in that orange zone, maybe it's going to move too much, right? Because the soil is moving right below that bottom edge of the ice. And so maybe you just try to find the sweet spot of where to put it. And now the consideration, of course, where we engineers come in is like, hey, let's just bury it really deep. Well, that's expensive. So we can't put it shallow because that's unsafe. So what is the right depth at which you can put this pipeline so that you balance economics and safety? What we engineers do for a living. Right. Also important to show is the difference between an iceberg that we all think of, right, to the right, That's when people think of floating ice, that's what they think of, right? Whereas an ice flow is younger ice, right? You have a sheet of ice that has became cold, it's just been developed, and as those sheets of ice compress against each other, they create these pressure ridges, and they have ice on the top and ice at the bottom. And so the strength of this ice is relatively much smaller than the strength of an iceberg as we think of it. Right? So now from an engineering perspective, you're thinking, okay, I need to think of, when it comes to interaction, I need to think of the ice, I need to think of the soil, and I need to think of the pipeline, because each one of them are three different materials. They have different strengths and characteristics and so on that are needed for input into design for ice scour. So I think this could be my last slide for now is, where does this matter, right? And perhaps the answer is, this is an old figure, it's 30 years old, where things are cold. And so in the Arctic regions of the world is where we're going to find this problem. So wherever we have offshore developments, offshore infrastructure with lines that need to come to shore, and those would be pipelines or cables of any sort, then you have to bury them to protect them from mobile ice that is scouring the seafloor.
So I have a question if you go back a slide.
Sure. I went back. I moved around a bit at this slide.
Oh,
No?
I have a question about that one too.
No,
but
no.
the one of your diagram.
This one. Sure.
Is that to scale? Like, is that how small the pipe is relative to the ice block? Technical.
No, I can't say I drew this to scale. It was more intended to be a sketch for illustrative purposes, but I guess it could be also to scale. Well, maybe not, because also the portion of the ice below the water line is going to be typically larger than the portion above the water line from a buoyancy perspective. So not to scale.
The host of our Scour, ladies and gentlemen.
Yeah, here I go. But how? So, like, when I first saw this, I was thinking exactly like you said. It's an iceberg, right? It's what sinks the Titanic. So how? Well, I guess walk me through how the younger ice is different in terms of a gouging. Are you just saying those younger ice pieces, are these still solid pieces that are coming through?
Well, I happen to have a prop on my desk, and it wasn't intentional, but think of this. Huh? Think of this glass of ice,
Excellent.
Water with some ice. That's essentially what's going on, right? Pieces of ice from these sheets are breaking off. You have an ice sheet that develops off a lake, for example, right? And currents and wind move it, and they crack and break in these compression ridges, and they have, they're not an ice cube, they're much bigger sheets of ice or pieces of sheets of ice that cinder together, right, and create the keel and the sail of this ice flow, right? So that's sort of the difference. When you think of an iceberg, this is something that has broken off an ice sheet, and it's multi-year ice, right? That has been in ice form for many years, much stronger, denser, right? Than something that may look like this, but still strong enough to scour the seafloor.
Can you talk then about some of the issues that climate change is causing for ice scour? Because as there's less ice pack, I mean, I have to imagine that more free-moving sea ice has to be a bad thing for scour, right? And probably seeing pieces in areas that maybe didn't get it in the past. I don't know. This could go down like 18 different avenues. There's your softball, Rodolfo.
I'm not sure if that's a softball, but it's a good one, right? Because people who have looked at, the nice thing about studying geology offshore, geosciences offshore, is that you can image the seafloor and look into it much better than you can do onshore with reflectors. And people who have been looking at this have seen that this is a thing of the past as well. For thousands of years, there's evidence of of areas that have been gouged, scoured, and infilled, right, over time. So we've been we've had this problem for a while. We just haven't had infrastructure that cares about it. As you're saying, with climate change, there's going to be more mobile ice. Maybe there's going to be less of these pressure ridges in areas that get warmer and therefore may not develop as much or as thick ice sheets, but with more ice breaking off of ice sheets and becoming mobile, then you have to deal more with ice management. And this is, if you go to Northeast Canada, somewhere like St. John's or Newfoundland, St. John's is in Newfoundland, and you go offshore, there's several developments that are gravity-based structures, like Hibernia and Hebron, and they have ice management programs. They have essentially systems in place and processes to protect their structures from the potential impact of ice. That's without it running aground and scouring. Now, if that ice were to keep on going, and they say, oh, we deflected it, let's send it to New York, maybe we can have ice in Maine, ice in New York Harbor. I don't know. That's my best answer to a softball.
I like it.
Yeah. So I understand the problem, ish. I got it. Let's put it really deep. We can't put it really deep. So how do you come up with the answer? Or how are you telling them how deep to put it? Is it a finite element analysis? Is it what are we using?
Yeah. So, step one is get out of that red zone, right? See if I can get that. So that's really not what a geotechnical engineer is going to help you much with, because that really is the ice engineer who's going to come in and say, look, we've studied the ice in this area, given its general strength and the conditions of the seafloor. We see, generally speaking, that it's going to have these conditions, and they look at past evidence of scour and their depths, and they can make analyses or can conduct analysis to make estimates of what is the 100-year, the 1,000-year ice keel. Okay. So they, just like we think of floods and earthquakes, they can develop to that environmental load condition, right? So say, okay, well, we got to get it out of the red zone, and the red zone is 20 centimeters, maybe changing units, maybe it's a few inches, it's 8 inches. And then come in the geotechnical engineers and say, okay, well, what's the displacement field going to look like? And of course, geotechnical engineers always answer with depends. And as you start looking at the mechanics of this, it's going to depend on, well, what's the angle of that keel? Is it sort of an acute angle, or is it a straight angle, right? Because that really changes the mechanics about how you push soil out of the way. Think of a boat sailing, and you see the wake it creates, right? It's the same thing. You're pushing soil out of the way. Right, and the flatter you are, you're also pushing it downwards, and so the mechanics of ice matter there, because then to push the soil downwards, you have a sort of a bearing capacity reaction, and the ice needs to be heavier, and so it gets complicated really quickly. So it depends also on, hey, is it clay? Is it sand? Is it silt? Is it all of the above? And so we try to figure out how to narrow this down. And geotechnical engineers typically narrow this down into sand or clay. And if it isn't one of those, then find somewhere in the world where it is sand and clay. And then it also becomes an interaction with the pipe. What is the pipe diameter, the wall thickness? How wide is this ice that is traveling, right? So you can make a list of parameters that affect the design overall and the interaction of the pipeline and the soil to develop the appropriate depth, or the best, or the safe depth, safe and economic depth, which you can bury the pipe.
So there must be some differences too in the the body of water, right? So you showed Kashagan, that's in the Caspian Sea. It's an inland sea for everybody out there. There's your geography lesson for the day. But I know this is also an issue on the North Slope, for example, in Alaska. How different is the issue of ice scour in the open ocean like that versus the inland seas?
From a design perspective, you're looking at potential differences in the ice itself. I was talking about, is it multi-year ice or is it the 1 year ice? You're also looking at differences in the seafloor. You're looking at duration also, well, exposure period and exposure time, right? In Kashagan, you only are exposed to this threat a certain number of months.
Yeah.
Whereas in the North Slope, you may be exposed to the threat for a longer period of time depending on ice mobility.
I would like to circle back to the statement ice engineer. Is that a thing? Is it a hydrologist in cold regions? What's this?
That's a good question, Stacy. And I think as much as I was working with them, I never really asked them, hey, what exactly, or maybe I did look it up, but what was exactly, how'd you get to this?
Right? Cool. It's a cool path.
And many of them would have started as civil engineers, and they end up with research into the mechanics of ice, right? And of course, a lot of the principles in terms of thinking of observation, going from an observation. So we observe earthquakes, measure earthquakes, and we make predictions of future earthquakes on the basis of the past. Statistically speaking, somewhat the same processes are done with ice. We're measuring what happens in terms of what depths of ice gouging do we see on the seafloor that are preserved by the time we went and measured them, because again, as it goes, you're going to scour and then it's going to infill, right? And so what can we learn from the past to predict the future?
So we do have some viewer questions coming in, and keep them coming, because this is what makes it fun, everybody, when we start getting this stuff. Stacy and I can sit here all day and ask, but
Brad pays me hourly.
So the first one we're going to get to is from Sean, one of our top viewers. He's here every time. And he asks, can an ice flow over time get close to the nature of an iceberg as water in the voids freezes?
I think that's a good question. And I'm not being an ice specialist, I'm going to go out on a limb here and say, yeah, the answer would be yes. And I think that's essentially how a lot of these, how you go from single year to multi-year ice, and how that the strength of it is increasing over time. Because as those initial rafted blocks cinder together, they will essentially congeal into one mass that is all ice.
One thing I wanted to ask about, and this maybe will show the world how nerdy Stacy and I are. I was in Winnipeg this fall in a little national park downtown called the Forks. And I'm going to hijack the screen here, Rodolfo, and show everybody what I saw. On one of the little informational signs, I saw this. First of all, whoever wrote the title for this signage, Flooding, Friend or Foe, deserved a bonus. That's amazing. But if you read down in there, you say, while regular flooding brings enriching food to the forest and river residents, the effects of excessive flooding and ice scouring can be seen in the forest around you. And this leads me into a question. I think, anytime we've talked about this, and I've talked about ice scour with Ming Xiao and a couple other people, it seems like it always comes back to oil and gas, right? But there are clearly other areas where this happens and other problems that ice scour is causing. Can you give a couple of examples for everybody that are outside the oil and gas world?
Well, I was going to go into the energy world.
Perfect.
Because it's where you bring infrastructure to land, right? And so if you have some other form of offshore energy generation, right? And now think of offshore windmills, offshore wind towers, and they have a cable, they have to lay a cable and bring it to shore. Then as you are proximal to shore and into shallower waters where gouging is a problem, then you have to protect that cable as well from the potential threat of a gouge, of a scour, of ice scour. Bridges are in many cases effective, but also by the massive forces of rafted ice against their peers. I haven't looked at this, but I can very quickly imagine that they also have the issue of just scouring the riverbed around the support, and that could be a problem as well for design, or a consideration for design.
That one was kind of fascinating to me in particular, and the reason I said we were nerdy is that I immediately sent the photo to Stacy and said something like "ice scour in the wild."
Did you do that in French or in English? Because I saw it's also.
He did it in French, and then I put the emoji with the little beret on it. It was great.
I think what was really interesting to me about that, though, is that this is right downtown in Winnipeg, like the city of like 1 million people. I never really thought of this as an urban problem, but I guess as you get farther north, it's an everywhere problem when there's water. I mean, sorry to keep putting you on the spot here. Do you have any specific examples where it's been an urban issue, or any case studies from more populated areas?
Let's get back to that one later.
Circle back. See if we have other questions.
That wasn't a softball at all.
I have a softball. I'm ready. I'm ready for one. So like what kind of, I mean, I'm more interested in your physical modeling, but what type of modeling have you done to calibrate your design?
Well, that's a good one. Thanks for asking.
You're welcome.
And I'm going to use some more slides for that one. Let's see here. That wasn't. Now. So again, when you're looking at the problem, you need to figure out, and you mentioned finite element analysis, what's the displacement field? What does it look like? And nobody has really gone out, put some instruments on the seafloor and figured out how much they've moved after a season. So we're left with trying to model this numerically. But anytime you're going to model something numerically, and literally millions of dollars depend on it, tens of millions of dollars, because again, Kashagan had about 1,000 kilometers of pipeline that needed to be laid, right? And every few inches cost quite a lot of money. Additional inches of burial cost quite a lot of money, right? In terms of time and overall cost by a contractor. So it justifies the development or the execution of physical testing, right? And so over time, people have looked at this from small little benchtop physical tests to the largest were the ones that we conducted. And so we in 2005 went to Deltares, and they have a flume, and they place compacted clay, and they build it in blocks, right? So this is the window through which you can see on the side. So these are windows here, so you can stand here and watch what's going on. They build a steel keel, and they have this gantry crane, and the idea was to sort of push the keel forward with 1 degree of freedom and measure the forces on the keel and set cameras on the side and see what was happening to these blocks of clay. and you can see that they put a quadricle on it to sort of measure what would happen. And that's what the before, and that's the after. And you can sort of see how the clay got smeared and pushed, right? And gives you a sense of what a displacement field really looks like. And again, you put a pipeline underneath somewhere, it's going to get pushed, and it may or may not survive that. That's me 20 years ago.
Look the same.
Just the same.
Just the same.
But then being in Texas, we got to do things big, and big we went. So, not having the advantage of ice in Texas, we had to deal with concrete and steel. And so we said, well, let's complicate things a little bit, and let's make keels and fill them out of steel, sheet metal, and we'll fill them with concrete. And we made one of 56 tons and another one of 47 or so. And they were different angles and different widths, right, to look at that. And so we then also had to build an area of sand and one of clay, compacted clay, right? But then again, look at the scale. And we would pull these keels from the back of a D11 Caterpillar. If you've never seen a D11 Caterpillar, I'm not there for scale, but this is twice my height. And this is the biggest dozer that Caterpillar makes. And so we put attached some cables to the keel. We instrumented it and measured. Again, nerding out a lot is and again, applying just free body diagrams. You want to measure the force, you want to measure the inclination of the cable, you want to measure the inclination of the keel, and you want to figure out where you are in the world. That's what we did there. And as I said, we did it in clay and we did it in sand, and we measured stuff. We buried a cable and we measured what would happen to the cable after it had been run over by one of these keels, and the scour is right there. And it was lots of fun. It almost killed me, but it was lots of fun.
Killed you how?
The amount of work that I put into this almost killed me.
Was this someone's ranch? Are we making a new subdivision and we just thought we'd just dig some holes real quick and then come back through? And what's going on here?
Bills of the subdivision here, but this was south of Victoria in eastern Texas, in someone's ranch. Yeah,
that's what when I saw Goliath, I was like, that's someone's ranch. Is it someone at Geosyntec? Like, you guys can come and just work out here. It'll be fine. The cows will walk back over it later. Don't worry about it.
That's right. So we had to, of course, build a fence around it so the cows wouldn't come and visit with us.
I knew it.
And make sure that the cows stayed outside. So these were some really nice folks that allowed us to play with dirt in their ranch.
That's so awesome for science, right? We'll let you tear up our land for science.
That's right. That's right.
Plus, cows like looking at new stuff. They were probably entertained for the entire time just staring at you.
You didn't know what was going on.
I don't know that they need the stuff to be new. I think cows just like looking at stuff.
I don't know. Cow looking at a new gate is a thing.
We have another viewer question from Thomas. How are tide levels accounted for in calculations? Does tidal action and buoyancy of the ice increase the rate of scour as the keel lifts and drops against the seabed?
So generally, yes, right? But what we're looking at is the overall effect of a season of scouring, right? And so tides occur twice a day, and they're going to be affecting this at a level that you're not discretizing, right? You're looking at, if I have a 100-year scour, right, at a certain depth, plus of a given width, and of a given angle, and of a given soil type, and so on. What are the stresses that that my pipeline or my cable will be subjected to? As you can see there, that cable wasn't initially bent a little bit, but then we measured it. It bent a little bit more, right? It's going to depend a lot on how close you are to the top of that cable. But yeah, soil is moving and displacing it.
So you just used the term 100-year, and I have to be honest, I don't think about Scour every day, so I've never thought about using a term like that in reference to Scour. Can you talk a little bit about some of the risk modeling that's happening around Scour and how you might predict some of those 100 or 500-year events and then prepare for them, I guess? I don't know. That was a very long, winding question. It probably didn't make a lot of sense. Sorry, but you know what I'm asking.
Well, I think so. Let me try to see, when we think of precipitation and storms, right, and we use terms such as 100 years and 1,000 years or 500 years as short form and many times too colloquially, right, to represent what is obtained statistically through what is likely to happen over a given period of time, right, of exposure. And so we think of earthquakes from that perspective as well. Not earthquakes per se. We think of ground motions that are caused by earthquakes from that same perspective. And so when you look at ice, it's temporal. So every year, in a given year, you may observe ice scours, and you think, okay, the deepest I got this year was 8 inches. But the next year you get several of 15 inches. And the next year you get several of 3 inches. And then 10 years from now, you get several that are 20 inches, and so on. And you can create a statistical model to predict or to develop what is my 100-year scour, what is my 1,000-year scour.
So I get that you said here that your pipe displaced a little bit when you hit it. I know you said the forces and things you were measuring, but what were you hoping to learn from these experiments? Yeah. You said you did it in 2005. You said it almost killed you. Thinking about doing it again, thinking about hiring some new people, forcing them out there for lessons learned, like what'd you learn and how have you used it?
Yeah, well, that's good too. I mean, we measured the power cable displacement, but we also had some instruments. Right, and again, for geotechnical engineers that may want to geek out here, on the left is my left. On the left, there's a pore water pressure transducer, right? So it's measuring the hydrostatic condition, and as the keel is coming from in time, of course, as the keel is coming, you can see that the pore pressure goes up a little bit, and then it goes negative. Meaning that it's, in this case, the sand is dilating. But it's semi-drained or undrained, and that's important in sand, right? And so it depends on the velocity. Again, another parameter that we geotechnical engineers get complicated with is the velocity at which this load is happening. And on the right side, I'm showing strain on a pipeline. So we buried a cable, but we also buried a pipeline, and we put some strain gauges on it. And I'm showing here, again, this is time on the x-axis, and then tension and compression, two diametrically opposite strain gauges. One gets bent and strains in tension, and the other one strains in compression, right? But what's interesting is that they end up with a permanent amount of strain. So they stayed displaced. Okay, still elastic, but they stay displaced. And then going back to the displacement field, we were measuring displacements, right? So there is no such thing as an instrument to measure displacement. but what we had to do were we thought of buying some big bolts. They were about 2 to 3 inch bolts, about a 3/4 inch diameter, and we put them in as we were compacting the soil. So we surveyed their location, and then after we scoured the clay bed and the sand bed, we went out with a metal detector to find them. Of course, each one was labeled, was engraved and labeled, and so as we would find them, we would survey them and then measure how much they had moved vertically and horizontally. And so you can see there on the plot to the right, it's showing displacement in the direction of the scour and the depth below the scour along which it's happening. And then on the other plot on the right is displacement in the direction of scour, how it from the center line, which is the middle, right, and the shape of those displacements that creates somewhat of a cosine function. And so now with this data, you can go back to the desk and say, okay, numerical model, match this, right? And if you match this, then you're calibrated. I can use you to design with more confidence.
So here you go, Brad. Here I go. How is your pore pressures? How are they different in your clay versus your sand site?
We didn't put instruments in the clay. It was partially saturated clay. You cannot get 25 kPa, 40 kPa clay under low effective stress without it being partially saturated.
How were your displacements different in the sand versus the clay?
Oh, you see how the x-axis doesn't have units?
Yeah.
Yeah, that's intentional because I can't tell you what the units are because that's under confidentiality agreement.
Fair.
So, sorry.
Okay. Well, that's all I got for that's all I can squeak out technically.
Which is fine because we gotta do some of the fun stuff too here. A lot of this work is happening in pretty extreme environments, and you gotta have faced a lot of challenges just doing this work when you're on site that other people wouldn't. You got any good stories for the crowd about being out in the middle of nowhere in Kazakhstan?
Well, I got to be honest with the crowd. I was never out there. India, because not being an ice engineer, right? Why would I be out there? But there are maybe people in the audience who were out there in Kashagan, right? Drilling holes in the ground, getting samples, and testing them, and providing acquiring the data that we needed to run analyses and understand what were the conditions in the Kashagan field. So to all you out there in the audience, thank you. I was able to be warm and comfortable in Texas while you guys were out there. I understand that. I've been out there in the field, but thank you anyways.
Well, when did you do your experiments on the ranch?
There's an interesting story there.
Still could have been extreme.
I was like, comfortable is a relative term in Texas.
That's right. And so this was say February to April.
That's quite nice.
2009. And we started putting strain gauges using these type of strain gauges that you have to glue on the pipe. Okay. And they're cheaper. And we started gluing them and under a canopy, and you're in the field, and they're really meant for laboratory type of situations, right? That was a bit of a learning experience. And then a front comes in. Okay. And I'm thinking, I had this project under a lump sum condition, right? I'm the project manager, and come hell or high water, I'm not going to go over budget. And so the front's coming in, and you combine that with dumb decision making, and I can't lose thousands of dollars here. And it's raining horizontally, it's blowing really hard, the canopy is gone, and I'm essentially bracing myself to the pipeline to protect it and holding the canopy with the other engineer that's helping me there. And at some point, I look at him and I say, "This has really become unsafe." And I shout, "Let it go." I let it go. It all blows away. We jump in the truck. We drive away. As we're driving out to Victoria to our hotel, we see flipped over 18-wheelers right on the side of the road, and dry ourselves out, wait till the next day. Come the next day, we had lost several $1000s of equipment that we had to come up with a better idea to replace.
I gotta say that story did not go where I thought it was
Really
going to go.
escalated
I
quickly.
thought you were going to talk about adapting some of the sensors you were using and stuff for use in sub-zero temperatures and things like that. I mean, which I guess could be the next question. Have you done any of that? Have you done any of that work so that people who are on site in these places can do some of this testing, or yeah, that's the whole
No,
question.
I mean, what we've always determined is that when you're going to do something of this scale, you need somewhat controlled conditions. So, and you're going to conduct this as a large scale. So, in the 2011 timeframe, I associated with Mike Paulin, who was at the time with IntecC and in St. John's, and Ken Bean, who was my mentor at Boulder, who was living at the time in Halifax, but traveling frequently to St. John's. And we set to put together a proposal to develop a large-scale facility in St. John's with some of the monies that are dedicated for R&D that come from applying taxes to the operators of the oil fields out there. So we were going to set up a facility in St. John's to conduct these tests for additional design or additional verification of design, and overall a large-scale research and development facility was the plan there. But yeah, I mean, we don't really go into the field to measure this or displacements or gouges. What happens many times when you have a project like Kashagan is that in every spring they go and they survey the seafloor, and they're looking for again, what I was mentioning is depth of the scour to develop and build up on the statistical model to better define the 100-year or 500-year or 1,000-year scour that is going to be used for design.
So, since you had the survey information, which is really helpful, if this was bridge scour, for example, we have all types of ways we're coming up to assess bridge scour, right? We all know that sending divers out or things like that are not ideal to know exactly what you have. So let's say you observe these huge gouges. Do y'all take like a bridge scour approach to it, like put a bunch of riprap on top and then let it hang out for the next year and try to infill it at all? Or is it too deep or too cold? Or
well, I mean, the idea would be to have, well, if you're talking about bridge scour, not sure. Not something I've practiced on, but when it comes to pipelines, you can also protect pipelines. If you can't bury it, you can try to protect it with rock dumping and mitigate whatever impact from the ice there may be.
That's what I was thinking. I'm like, oh, I got really close. Okay, let's go put some rocks on top, and then maybe they'll slow it down next year.
Rock dumping on pipelines is definitely a thing that is done to protect pipelines from impact.
Okay. Yeah, how much? I mean, I know enough about pipelines to be dangerous from a corrosion perspective and like how they're putting holidays in it and how they're assessing it from that side. But do they monitor it from the same perspective, or like you said, just mainly from the checking the seafloor because it's so?
No, I mean the pipeline engineers and really corrosion is a whole different line of engineering, but they run inline inspections quite diligently to identify areas of corrosion. Right? And so they run their pigs, their inline inspections with pigs in the pipeline that are running instruments that are detecting, that are constantly scanning and detecting anomalies in the wall thickness that can lead to leaks, right?
I guess my question was poorly worded. I was wondering if you could use like a pig to tell if you've had displacement from like an ice impact.
Yes, you can. Yes, you can. Okay. And so we use these quite regularly for, every operator uses them to identify how a pipe may move onshore, right? Wherever pipelines are running due to landslides or subsidence or anything else like that. And it's called an IMU, or the acronym is an IMU, and I'm going to mess it up.
Inline.
I'm not going to try right now. This should roll off my tongue, but it's not doing it right now. But it provides you a sense of bending, of direction of the instrument, and you can develop a sense of how much it has bent over time, particularly if you do it year after year, and you can see what has happened.
That'd be cool. Sounds like a fun little master's project. I can see what's on the surface. I see what's in the pipe.
Which is ultimately what matters to the pipe, to the people who are designing this, is what happened to the pipe.
Yeah.
Don't tell me what happened to the ice. Don't tell me what happened to the soil. All I care about is my structure. Did it move? Did it not move? By how much? Did you get it right?
Cool. Do we have any other questions from the public, Brad?
We don't. If you've got one final one, we can make this our final call for questions. So if anybody out there has anything else that they're dying to ask Rodolfo, or I guess you could ask us too, but really Rodolfo's the star here today. Got anything else you want to put in? You've got about a minute at this point. Stacy's going to come up with something brilliant to wrap up the interview with. And so that's your cue, Stacy.
I'll just give a shout out to.
Oh, absolutely.
This is where I was going. Yes.
4 people I wanted to mention. And this was I see it's a blurry photo, but Ken Crosdale was the ice guy here, right? And Ken Bean was my mentor at the time, and he was the soils guy, and Andrew Palmer was the pipeline guy. George Comfort was the overall engineering and modeling guy, and so all together it was a great team to be able to be exposed to and work with. And this was June 2005, some time ago. But yeah, that was those tests at Del Terrace in the Netherlands, in Holland.
Sorry. Cool. Yeah, I was going to ask how where we never got to, how did you become the ice scouter guy? Like, how did you get in this path to go down and do this type of experiment and do this type of design? I mean,
yeah, it was Ken who would challenge me. Right, shows up in my office and says,
"No problem for you."
Yeah. Right? And like, yeah, let me find out all about it and spend the next 3 days without sleeping to understand what it's all about, and then come back to him and like, look, I learned. And so it was about having a great mentor that would challenge you and bring you into some cool stuff.
That's amazing. I'm glad we got that, because we didn't do it at the beginning like we probably should have. But, that's the magic of the GI YouTube channel and Hour of Scour, is that you get everywhere you need to go. So there are no more questions in the chat. So this is the time where we say thank you, Rodolfo. Thank you, Stacy. It's another amazing episode of Hour of Scour in the books. For our viewers, thanks for hanging out with us today, especially those that ask questions. We really appreciate it. That's what makes this a good time, is when we get questions in the chat. If you liked what you saw, and if you're here at the end, you probably did, again, click like, subscribe, get notifications. And if you do those things, they don't even have to be in that order, but they probably should be in that order. We'll let you know every time we post something to the YouTube channel. So Rodolfo, thanks for that amazing presentation, and Stacy, another amazing hosting job today, and we made it. We'll be back in 3 months, I guess, with another Hour of Scour, and we're forever indebted to you, Rodolfo, for inspiring this series in the first place. So that's like a double thanks, I guess.
Thank you. But we didn't talk about baseball or Venezuelan food.
We didn't. So if anybody out there wants to talk about baseball or Venezuelan food, you just reach out and we'll make sure we got you hooked up. If you want some of the goodies on that, you can go back and watch Rodolfo's episode of Director's Cut from, I think it was season 3 that he was on. So you want to go check that out. Our next live stream is coming up in 24 hours. We'll be back here on the YouTube channel with Geo-Congress 2026 sneak preview number 1. Lauren Anderson, yes, the Lauren Anderson that was the chair of the first Geo-Congress back in 1997 that was held at Utah State University, is going to be presenting the case history of the Teton Dam failure in 1976. So cool case history presentation, a little bit of geotech history there as well. You're going to want to be around for that. And then on Thursday, again, we'll be back at 2 p.m. with the McAferry live series. We'll be talking about rockfall, drapery, software design. So we got a lot happening this week. Our producer today was Aurora Flieger. And we will see everybody in, again, less than 24 hours with another Geo-Institute live stream.